Hey guys, welcome. This is our 10.5 video. We're going to do 3 problems today, and we're looking at regular polygons again, and we talked about them before, and we use special right triangles. So today we're going to be doing it, but this time not with special right triangles. We're going to have to use trigonometry. So let's go ahead and jump into this problem. The first problem is, what is the area of a regular nonagon, that's 9 sides by the way, with 10 centimeter sides. So I'm going to actually let kind of the computer do some of this work. We'll talk about it as it goes, and then you can write what I get written down. So there we go. There's a nonagon, center C, and it's got 10 side. We can draw a triangle in here. This is an isosceles, right? Because the distance from the center to the vertices are going to be the same. Moving on around, we want to find the central angle. So we do 360 divided by the 9-sided nonagon. So we get 40 as our degrees, and our perimeter is 9 times 10 or 90 degrees. Draw our apothem as CS. Again, the apothem is the altitude of the isosceles triangle. The apothem bisects the central angle, and it also bisects the side of the polygon. And there we go. And moving on down, since it bisects that 40 degrees, we're going to get 20 degrees right inside. And if I move my face, haha, there it is. And we get half of the side length of 10, and we get 5 as our side length. Okay? So, whoops, pause it right there. I want you to write all of that down. Okay, so I want the words over here, and I want the pictures over here to write down. Okay? So pause it, write that down. Moving on forward. Now let's go ahead, and I'm going to help you guys solve the rest of this problem. Okay, we need to find A. Now before we could find A using special right triangles, we can't do that anymore. So what we're going to do is we're going to use some trigonometry. So if we put some eyeballs down here at this angle, sorry, not at that angle, blah, what am I doing? We don't want to put the eyeballs down there, we don't know the angle. We want to put the eyeballs where we know the angle. So we have the 20 degree here. So we're going to put our eyeballs right here. We have opposite 5, and we have adjacent is our A. So we're going to use tangent. So the tangent of 20 degrees should equal opposite 5 over adjacent. Again, when we have the variable in the bottom, these two can switch positions. So we're going to get A equals, one moment, sorry, back to it. So when we have the piece, alright, sorry, back at it. Woo! Alright, sorry, okay. Anyways, so the tan 20 is up here, A is down there. Algebraically, these two can switch spots, and we can go ahead and find the measure of this. Okay, so we're going to have to use a calculator to find that measure. 5 divided by the tan of 20, and we want to make sure that we are in degree mode on our calculator. And we get the apothem to be about 13.37373. I like to try and go out maybe at least 4 spots to be a little bit more accurate, because we're not going to get a nice rad number or anything like that. So here's our apothem. Now the formula stays the same, where we get 1/2 apothem times the perimeter. So we're going to get that 13.7373 number times our perimeter, which we found earlier was 90, and then we're going to divide it by 2. So really the only difference is we're using trig to find the apothem, which actually I think is almost easier than using special right triangles. So a lot of times you can just leave it in your calculator. So I already have it left in there, so I'm just going to multiply that by 90 and divide by 2. Okay, and we should get roughly the area is about 600, if I can get this to work, there we go, 618.18. And we'll round that to the nearest tenth there, and that's going to be square centimeters. Okay, and that's our final answer. Alright, boom, let's do another. Okay, so here we go, and let's move to this question. Let's look at a pentagon. This time we'll do all this one ourselves. So a pentagon is 5 sides with 4. So if we put this, we draw this little triangle in here. Again, we're going to find the central angle, so that's going to be 360 divided by 5, not 4. So this is the central angle. Okay, so 360 divided by 5, we're going to get 72 degrees. But remember, the apothem is going to cut that in half. Okay, so we're going to actually get half of that, and we'll get 36 degrees right in here. The apothem will also cut the side length in half to give me 2. And here's our apothem. Okay, so over here, let's go ahead and write our formula. We got 1/2. Apothem we don't know, perimeter we don't know. Okay, we can find the perimeter. It's just going to be 4 times 5. So the perimeter is pretty easy, 4 times 5. And so we get 20 for our perimeter. And then to find the apothem, I'm going to go ahead and draw the triangle out. So the apothem was here. We have 36 here. Okay, and down here we have 2. So put those eyeballs up here, and we're going to go ahead and get a very similar response for a lot of these, and that's going to be opposite and adjacent, so we're going to get tangent again. And the reason why is because they keep finding themselves in the same spots. Opposite is 2 over A. Again, those are going to switch spots, so the apothem is going to be 2 over tan 36. So we're going to use our calculator, 2 divided by the tan of 36. And A, our apothem, is going to be equal to about 2.7527. So we plug that in over here, 2.7527. I'm just going to leave it in my calculator. So we have it there right in my calculator, and I'm going to multiply that by 20 and divide by 2. Okay, so, whoops, accidentally deleted it from my calculator. So there we go, we got it. Times it by 20, divide it by 2, and our area for this pentagon is going to be about 27 point. We're going to round to the nearest square inch. So I would actually round this to 20.7. It's 5.2, so I'm actually going to round that 0.5. We'll round up to 20.8, and that's going to be square inches. So that would be my better answer there, not that one. Okay? Boom. All right, one last problem, and we're going to switch things up a bit. We've been dealing with the side. Now let's look at another shape where we don't have the side, but maybe a different piece. Bum ba-dum bum 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 ba-dum bum bum bum. So, how are you guys doing? Just waiting for this to load. Seen any good movies lately? No? Yeah, me neither. Okay. Let's take a look. It says a stop sign is a rectangular octagon. So we got octagon here. The standard size has 16.2 radius. What's the area of the stop sign to the nearest square inch? I believe they help us out with the picture here, and we'll go right to there. Okay. So now we have this piece, but we don't have this piece. So we got to do actually a little extra work on this problem. But we have an octagon here. We can still find that central angle, so that's our first goal, is let's find the central angle. And we get 360 this time divided by 8, and that gives me 45. But we want to cut that in half, and we're going to get half of that right in there, and that's going to be 22.5. Okay, so let's draw this triangle out. We have 16.2 We got 22.5. Here's my 90. I want to find my apothem, and I also want to find my opposite side. So we'll call this S for now for side length. Okay? So let's go ahead and I'm going to pick a different color here. Let's go blue. So eyeballs up here on the angle, we're given the hypotenuse. Let's find our apothem first. So that's going to be HA. So we're going to do the cosine of 22.5 equals, it's adjacent over hypotenuse, so adjacent over hypotenuse. And we're going to multiply that 16.2 out, and we get 16.2 times the cosine of 22.5 equals A. So let's multiply all that in there, which is nice. 16.2 times the cosine of 22.5, and we get about 14.9. So in our area over here, we get 1/2, and we're going to get our apothem as 14.9668. Okay? Alright, so that's pretty good. We'll go ahead and erase this, so make sure you got that down if you didn't. Okay. Now we want to find our opposite, so we're going to find our side length. And to do that, we are going to use opposite and hypotenuse. That's going to be the sine of 22.5 equals 5 over, or sorry, not 5, that's an S. Wow, good thing my S's look really good. Let's do that again. This is S for side and 16.2 on the hypotenuse. We're going to go ahead and multiply that across. 16.2 times the sine of 22, that's a 2.5, equals our side length. And that's really only half our side length, so we're going to have to double that. 16.2 times sine of 22.5, and we're going to get the side is about, and this one I'm going to round a little bit easier. It looks like it's about 6.2. So that's this piece right here, 6.2. So I got to double that, and that should give us about 12.4 for the side length. And if we go ahead and multiply that number by 8, because there's 8 sides for our for our perimeter, we should come up with our perimeter as 99.2, and that's for the perimeter. And we did that by doing 12.8 or 4 times 8. Okay? And so that's how we got, from here, we got to that number. Alright? Now let's throw all that in our calculator, and we are done. 14.9668 times 99.2 divided by 2, and we get 742 point, I'm going to round to the nearest square inch, so I think we just stop it right there. That's our answer. Let's put in our appropriate units, because we're talking about square inches. And we're good. So, not the easiest problems. We'll get used to them. We'll practice, and we'll see you guys over now.